This video demonstrates the operation of two workloads equipped with Hopr sidecars and exchanging end-to-end encrypted messages without a key exchange. The video also demonstrates how untrusted endpoints, or those without a correctly configured Hopr sidecar, are prevented from connecting to any trusted workload endpoint. Here we have communication between two cloud endpoints. At the top, we have the Babar endpoint, and it's communicating across the internet with the Cornelius endpoint, shown at the bottom. And you can see that Babar is getting a response back. Every 30 seconds, the Babar endpoint is starting a new session with Cornelius via a Hopr sidecar, and Cornelius is separately doing the same thing but in the reverse direction. Its sidecar is connecting and starting new sessions with Babar. Communication is happening over the internet with end-to-end encryption through the Hopr sidecar using the synchronous ephemeral encryption protocol. The actual curl command from Babar to Cornelius and vice versa is not encrypted. You can see here that our endpoint is connecting to an unencrypted HTTP web server, so there isn't any TLS or other external service involved in encrypting the messages. Symmetric keys are generated in the sidecar and remain there for encryption or decryption, and messages are protected over the entire route. If a third endpoint appears, which happens to be my laptop, and tries to connect to Babar, you can see that we don't get a response back. The communication that is occurring from the third endpoint to Babar is initiated and travels over the internet and into the sidecar at Babar. But it fails decryption and is black holed by the sidecar. No response is returned to the sender. This is very useful when you have application endpoints on the internet because any type of response, even rejections, can positively identify the existence of an application. So the sidecar is black holing the untrusted and potentially malicious traffic. All such messages are effectively being dropped, including any that contain TLS encrypted malware. But if this third endpoint was a trusted endpoint, all we would need to do is activate the Hopr sidecar with correct CHIPS algorithm on the third endpoint. Although the third endpoint cannot access the Babar endpoint directly, when we send its message to Babar through the Hopr sidecar, you can see that we have accessed the sidecar listener port on localhost, and the message is decrypted by the sidecar at the Babar endpoint. The symmetric encryption occurred without a key exchange or handshake, and it's continuous between the third endpoint and the Babar endpoint. And every single communication session that is initiated by a sidecar will generate a new key that is based upon the aggregation of dynamic internet information. This produces separate keys for sessions conducted by a single host pair and also sessions between different host pairs, but all using the same CHIPS algorithm. You can learn more at hopr.co.